Good morning, HVAC team. Hopefully everybody's staying safe, staying healthy. Um, I've been staying home and trying to follow the rules and, stay out of the crowded areas and everything so I can stay healthy. So far, so good. I don't have no weird symptoms or nothing. Hopefully the same is true for you guys. Um, so that being said, we're going to move into chapter 81, which is chilled water systems. So let's go ahead and get into that. So chapter 81, the objectives are describe the difference between a flooded and a dry type chiller, explain why low pressure chillers need purge recovery, explain why some chillers are better suited for air-cooled condensers while others operate with water-cooled condensers, list the different types of compressor arrangements found on chillers, describe the function of a chiller economizer, describe the operation for an oil return system for a chiller, transfer refrigerant to and from the chiller, and explain how an absorption chiller operates. So, I don't know why my nose is bothering me. My allergies are tripping today, but excuse me. So, chill water systems. The more common way to deliver refrigerant to individual air handlers is to use a secondary refrigerant, such as chilled water. The chilled water is cooled in a central station chiller by a primary refrigerant. The chilled water is then delivered throughout the building to individual air handlers by circulating pumps. So the primary refrigerant will be your actual refrigerant, and then your secondary refrigerant is the chilled water, and it's being chilled at the evaporator, at the evap coil, just like in a regular, excuse me, just like in any refrigeration system, excuse me. Instead of the return air from the room going across the evap coil and then coming out the other end as conditioned air, with the chiller system, it's absorbing heat from the water. So you got this big tank, your evap coil is just this big tank of refrigerant with these tubes of water flowing through it, and that refrigerant is absorbing all the heat from those tubes of water and sending that chilled water out to each individual cooling coil in the various air handlers in the building. So that's how the chillers work. That's how you get your cooling. So the primary refrigerant is your refrigerant. Your secondary refrigerant is the chilled water that's going to each individual air handler. Flooded and dry type water chillers. The water in a chiller is cooled to approximately 43 to 45 degrees Fahrenheit. The chilled water pump circulates the chilled water supply to the cooling coil in the air handler. The chilled water loop will have an expansion tank and fill connections for makeup water, and it will have air vents, balancing valves, and cooling coil flow control. Purge recovery units and air-cooled condensers. So a low-pressure chiller will operate with a negative suction pressure that is below atmospheric. Any leaks in the system will draw air into the system. This air typically collects in the top section of the condenser. The air will increase the discharge pressure of the unit and lead to higher compressor power consumption. The air will also contain water that will oxidize. I'm sorry, where did I leave off? Okay, the air will also contain water that will oxidize the oil in the system and lead to the formation of sludge and acids. Chillers of this type generally have some type of purge recovery unit. Never allow a low pressure chiller to reach or exceed the rupture disk setting when testing for leaks. The rupture disk setting for low pressure chillers is normally set at 15 psi, but it is advisable not to exceed 10 psi. If this happens, then the chiller rupture disk will release and all the refrigerant in the unit will be lost. So when you're leak checking, it's a lot of times you want to try to get the pressure up so you can exploit the leak, but You don't want to get that pressure above 10 psi, or you're getting into the danger zone of rupturing that rupture disc and blowing whatever refrigerant is left in there. And then as far as the recovery unit, so like it said, the suction, the evap coil, it operates at a negative pressure. So if there's any leakage in the system, it's going to be drawing air in from outside. And you don't want all that extra, you don't want that air inside of your system. You want nothing but refrigerant in your system. So when you have air in the system, it's going to increase your operating pressures. You can damage your compressor. Also, that air contains water. So water and refrigerant makes acid, and then you'll have acid in your system. So you want to remove that air, which is why they have these purge units. The purge recovery units, it draws in that air. It draws refrigerant in too, but it recirculates that refrigerant back into the system while throwing the air out of the top. So you get rid of all your unwanted air and you keep your refrigerant. So that's the whole purpose and function of the purge recovery units on these low pressure chillers. Air-cooled condensers. Starting at the lower capacities, packaged water chillers used on one or more reciprocating compressors. I'm sorry. Packaged water chillers use one or more reciprocating compressors. This type of unit would be mounted directly outside or on a rooftop with supply and return connections for the chilled water piped into the building. For head pressure control, the condenser fan control receives input from a pressure transducer. The fans are maintained at the lowest condensing pressure and temperature possible to maintain the highest unit efficiency. Air-cooled condensers. The larger packaged chillers with reciprocating compressors can be air-cooled or water-cooled and range upward from 40 to 200 tons. The cooler and compressor can be located indoors, and the air-cooled condenser located on the rooftop or outside of the building. Excuse me. That one of the benefits to water-cooled condensers is that the coil can be located indoors because it's being water's being pumped to it to remove the heat. Air-cooled, obviously, they would have to be outside in the air. So those are some of the differences. Scroll compressor chillers. In addition to reciprocating compressors, the scroll type compressor is being utilized increasingly in packaged chillers. These compressors use a pair of mating scroll-shaped surfaces to compress the refrigerant with pure rotary motion. So that's how the scroll compressors compress refrigerant. They use those two scrolls in that rotary motion. So this is really irritating. I'm sorry. Anyways, yeah, so compressors, they all do the same thing. They compress refrigerant. They turn the low pressure gas into high pressure gas. They just have different mechanisms for doing so. Centrifugal compressors. Centrifugal compressor chillers. Hermetic centrifugal compressors vary in design and refrigerant type. This unit is a hermetically sealed motor that will drive the compressor through a set of transmission speed increasing gears. The compressor speed is typically much higher than the motor speed. The refrigerant vapor is drawn from the cooler into the suction eye of the rotating impeller. The pressure of the refrigerant is increased as it passes through the discharge of the spiral compressor casing and into the condenser. My allergies really giving me a hard time today. Excuse me. Centrifugal compressor capacity control and screw compressor chillers. Variable speed prime movers may also have limitations in speed and reduction and only operate within a specific range. To accommodate this, most centrifugal compressors will have variable inlet guide vanes located at the compressor suction. These vanes will be closed at low load and at compressor startup, and then open at high loads. An important type of packaged water chiller uses the helical rotary compressor, commonly known as a screw compressor, because the appearance of the rotors. Screw compressor chillers. The twin rotor screw compressor uses a mating pair of rotors with lobes that rotate much like a pair of gears. Screw compressors are used because of their high capacity for a small unit and their continuous variable capacity control, typically modulating from 100 to 10% of full capacity. Being positive displacement, screw compressors have piping flexibility to accommodate remotely located condensers and can be used with high pressure or low pressure refrigerants. They can operate both with water and air cooling. Cooling water towers may be used for closed loop water cooled condensers. Okay, screw compressor chiller operation. A hermetic screw compressor drawing suction from a flooded cooler. So that's what we have here. The refrigerant vapor is compressed and discharged into the condenser. A flow valve will control the refrigerant flow and allow for the pressure drop required for the refrigerant to expand in the cooler. A hot gas bypass solenoid operated valve is used to recirculate refrigerant at low loads. So the chiller system, just a quick review, it operates the same as any other refrigeration system. We have our compressor here, which is the heart of our system. It's going to pump our gas, our high pressure gas, into our condenser, and then it's going to condense into a liquid, and it's going to shoot that liquid through our metering device into our evaporator coil, and then it's going to go through our suction line and back into our compressor. Same exact cycle, same four major components: compressor, condenser, metering device, evaporator. Same thing. Only difference is the heat transfer is taking place between the refrigerant and the secondary refrigerant, rather than the refrigerant and the air that's being conditioned. The secondary refrigerant is the water. So the water is being cooled because the refrigerant in the evap coil is absorbing all the heat from the water and pumping that chilled water to our cooling coils, and then the heat from the discharge gas is being absorbed into another water loop that goes out to our cooling tower, where the heat is removed. So many large commercial centrifugal and screw type chillers utilize economizer sections. Their purpose is to subcool the liquid refrigerant before it enters the cooler. Chiller oil return. A typical oil return system for a hermetic screw type compressor chiller is what we're looking at here. So a metered amount of oil collecting in the bottom of the cooler is allowed to pass to the vaporizer section. Let me just scroll down a little bit. Hot gas from the condenser passes through a coil located in the vaporizer. This will vaporize any liquid refrigerant that has been carried over with the oil. The oil then passes from the vaporizer to the oil sump, where an electric heater is utilized to further vaporize any refrigerant liquid entrained in the oil. Mist eliminators are used to remove any entrained oil in the refrigerant vapor before returning to the compressor section. This reduces the possibility of any oil carryover that will slug the compressor. So it went through all of these different precautions to get rid of the moisture or get rid of the liquid refrigerant, which again tells you liquid in the compressor is a no-no. Compressors are vapor pumps, not liquid pumps. So the liquid refrigerant can be trapped in the oil. And before that oil goes back to the compressor, we got to make sure we remove all that liquid. So that's why they're heating it up through this process. Chiller refrigerant recovery and transfer. So this system is permanently installed and can be used to transfer refrigerant from multiple chiller circuits. Chillers that do not have permanently installed transfer systems will require a portable unit. This is different from conventional portable recovery units because of the valve arrangement. Absorption chiller operation, absorption cycle components and operation cycle. So the refrigerant used in absorption chillers is just water, and the absorbent is lithium bromide. The evaporator shell pressure is reduced to 0.12 psi. At this low pressure, water will evaporate at 41 degrees. So that is your absorption chiller operation. So in summary, air conditioning chillers are typically designed for indirect expansion. Chilled water is circulated to individual air handlers or fan rooms rather than the primary ingredient. Chillers come in various sizes with smaller tonnage units utilizing reciprocating and scroll compressors with electric motor drives. It is important to understand the refrigeration cycle and operation of a chiller before transferring refrigerant. Always remove liquid refrigerant from a chiller first before recovering the vapor or charging a unit. Failure to do so could result in chiller freeze up and damage. Never charge liquid refrigerant to a chiller that is under a deep vacuum. Never raise the pressure in a chiller above the rupture disc burst pressure, and follow all manufacturer recommendations and procedures when servicing a chiller. So I have to apologize. My allergies are really bothering me today. I'm not sure why. So sorry for being gross during this lecture, but hopefully that was helpful. Again, read your books. The chapters go a little bit deeper than this lecture. So you want to, definitely watch the video, read the chapter, and that should get you through your review questions, which are on FlexiQuiz, by the way, and also that'll prepare you for this week's exam coming up at the end of the week. So hopefully everybody's staying safe, staying healthy, staying home, and staying engaged in their studies. We will be back to school at some point. I do not know. I've been hearing sometime in May, but I hear all kinds of stuff and things change all the time. So I will let you know for sure when I know. So until then, take it easy, and I will see y'all on the next one.